All right, it's 3 o'clock, so we can kick things off. Good afternoon, and thank you for joining us for the 2021 WiSys Prototype Hackathon. My name is Tony Hansen, and I am the WiSys Regional and Licensing Associate serving the Southern Wisconsin campuses. As an organization, we are proud to serve the inventors and innovators on our UW system campuses. We are also excited to be able to bring you events like this as part of our vision for building a culture of innovation for a better future. Now, first held in the spring of 2016, the Prototype Hackathon was launched to engage students to design innovative product prototypes and demonstrate their commercial relevance. Now, just like the ideas and prototypes you'll hear about shortly, this competition was born from the vision of UW-Platteville students. Our first group of WiSys student ambassadors at UW-Platteville wanted to hold an event that could highlight the creativity on campus and provide a platform for students to develop and present their pioneering ideas. This competition is now a signature event on campus, and this year's event marks the 5th Prototype Hackathon at UW-Platteville. For the first 4 years, and once again this year, the Prototype Hackathon has been made possible thanks to support from the Platteville Regional Chamber, the UW-Platteville Office of Research and Sponsored Programs through the Student Research and Engagement Fund, and the UW-Platteville College of Engineering, Mathematics, and Science. We thank you for your continued sponsorship and partnership, which are essential to make this event a success. To provide our attendees some additional insight into the format of this event, the teams presenting today had one structured day to design and build a prototype. Over the course of the following weeks since that build day, the teams have worked to improve their prototype, conduct their market research, and craft the presentations you'll hear this afternoon. Overall, this competition has provided students the opportunity to develop and showcase their original work. Today, the judges will be scoring the teams on the novelty of their prototype, their analysis and research of the target market, their plan for future development, and of course, the overall quality of their presentation. We are lucky to have with us a panel of 5 esteemed judges. Judges, please turn on your camera and give a wave as I introduce you. I'd like to welcome Darren Dreesen, Director of Open Innovation and Managing Director of 1915 Studios at Georgia-Pacific, Dr. Jody Procyse, Chair and Professor of Mechanical and Industrial Engineering at UW-Platteville, Dr. Wayne Weber, Dean of the College of Business, Industry, Life Science, and Agriculture at UW-Platteville, Wayne Wodarts, Executive Director of the Platteville Regional Chamber, and Brad Ricker, WiSys Regional Associate. Thank you all for taking the time to be here today. Now, without further ado, let's turn things over to our student innovators. Each team will be introduced and cued to start their presentation. At that time, please turn on your audio and video. After each presentation, we will bring in the judges and they will have the opportunity to ask questions. In the meantime, presenters and judges, please make sure your audio and video are off. Attendees, thank you for joining us today and best of luck to the presenters. First, we have Joseph Watching and Jonas Gillies to present their prototype. You may begin once your slides are queued up.
Okay, so hello everyone. So my friend Jonathan Giles and me, Joseph Watchen, we're presenting a new way to produce carbon fiber parts. Can you go to the next slide, please? So what is the problem here? So to produce carbon fiber parts, right now, we have 2 processes in the world. We have to produce the molds in CNC machines that is really expensive. Or we have a cheapest way to do it that is producing those molds in fiberglass, but the labor hand is really expensive too. And the other problem that we have is like countries in Latin America or in Africa, they don't have access to those machines because those machines are really expensive there. And import the parts are really expensive. So just as an example, a prosthetic legs cost like not less than $5,000. That is really hard to access in, for example, in my country that is Peru. Next slide, please.
Okay, our solution for this problem was to come up with a way to 3D print carbon fiber molds. We have an example right here. This is our mold for our prototype. We developed this technique to save on cost and on one hand on labor costs, because this can be printed on a 3D printer. So as soon as the mold is designed, the part can just be printed. There's no one needs to be there. No one needs to take care of it. We actually believe it is quicker to 3D print our molds compared to a traditional carbon fiber mold, mainly because our mold takes around 3 days to print. And I know some of the fiberglass molds, they need days of drying time. You have to lay multiple layers of different composite materials, which just increases the production time of these molds. And in any process of that mold production, a person has to be involved. So there's a lot of labor costs. Next slide, please.
So how is the market? Like in 2017, the world produced 70,000 metric tons of carbon fiber. That is like approximately $160 billion. And it's expected that next year it will be increase of the market of $218 billion. That is a lot. So as you can see in that chart, in the pie chart, the 52% of the market is in the aerospace and automotive industry. But there is also like a market that is not taking care of the company, that is sports and leisure, because to produce a part for a person that lost his leg or her leg, you will need to make like a specific one part for that person. And if that you want to produce another part for another person, you will need to produce a different specification, because that person might be taller or lower. So we don't know, right? Like to produce, we cannot produce like 1,000 of parts, like we're producing, for example, for a car industry. So over there is a really good market to produce like not too many parts as we are accustomed to do in high industry. Next slide, please.
Okay, so for our next steps, we can present our prototype. We actually have a functioning carbon fiber prototype, which we produced for a friend of ours who wanted a sport running sort of carbon fiber leg instead of his normal one. We see a lot of improvement steps that we can take. One big thing we want to improve is we would like to use more industrial materials. Just because the materials we have at hand and with the budget we were given, we did the best we could, but we feel that can be a large improvement by using industrial materials for certain steps of the process. We would like to make more experiments and standardize our process to have the best outcome possible, the best quality products possible. We already have a list of improvement steps we want to take and experiments we want to perform. We would like to validate our process. So we would like to go and talk to companies that produce small batch carbon fiber pieces, which, as Joseph explained, is our main target. You know, companies that produce a few hundred pieces and then change their design. So we believe that our process can really respond to quick changes in your design. Within a few days, you can have a new mold completely printed and ready to produce more parts, as well as reaching out maybe to companies that produce prototype parts. Our process would be very good for checking if a mold that is to be CNC cut would even work out. So will be good for prototyping molds, for testing the first carbon fiber pieces of a new product. And the lower cost nature than the other two processes really lends itself to these prototyping and small batch production. So we want to get in touch with some companies that focus on that, see if they were interested in testing our product, and gather feedback, and then improve our process further on from there. Next slide, please. Okay. Does anyone have any questions?
Thank you, guys. This is Brad Ricker, and I guess I wondered, you did a good job of spelling out how you envisioned taking this to the market in terms of engaging with potential clients. But how would you deal with the scale if you get a client and you go into actual production?
So the nice thing is 3D printing is a technology that right now and for the past few years has really been entering industry. And there's a lot of, well, it's not as expensive to buy multiple 3D printers and to produce more molds at the same time than it would be to buy, let's say, a CNC machine. Right, buying a 3D printer, even an industrial 3D printer, might not be as expensive as buying a CNC machine to have a larger production volume in the same amount of time. So that way it would be possible to focus on supplying customers with more of our molds in a fairly short time by just setting up space and getting more 3D printers to produce more molds at the same time.
Couple of questions for you. Any concerns, excuse me, from like a temperature perspective or pressure perspective when you're using the materials that are typical of a 3D printer?
That's actually a really good question. So our prototype is about 8 millimeters thick. It did produce a little bit of heat, but if a carbon fiber piece would exceed 200 degrees or 180, which is the point at which the material we use, the PLA, becomes soft, the carbon fiber piece would actually start being damaged. It would start bubbling and the product wouldn't be possible to be produced that way. So if companies produce thicker pieces that have a higher tendency to produce more heat, they cool them, which is something we did. We had a casing around our product and we used water to cool the process and to cause the resin to not bubble, not to cure too fast, and not adhere properly. And the plastic, we can actually use industrial 3D printing plastics that have a higher melting temperature. So if there's a need for higher temperature processes, we can even buy better quality plastics.
Great. And last one, any concerns from like if you're thinking about the size of your market and where you might take this? Standard build envelopes for 3D printers aren't that large. Do you see a path to like maybe multiple piece molds, or how do you address the build envelope limitations in your market?
That is a really great question. On our mold, we made it on a normal desktop 3D printer. So it's a 3-piece mold with sort of puzzle piece connections and bolts. But with my background in 3D printing and stuff like that, we could develop, and I have developed a process like my own larger 3D printers. 3D printers are very scalable. Production volume could be increased by using larger extruders and then finishing the surface to get a great surface finish and quickly produce larger part. Beyond that, I know there are some companies that specialize in large 3D printers. I know of one company from the Netherlands that produces large 3D printers for industrial applications. So those are all options to look at.
Great, thank you.
Okay, thank you, Joseph and Jonas. All right, so next we have Ben Oberbrockling to present his prototype. Ben, you may begin once your slides are queued up.
Okay, thank you.
Okay, thank you. So just so you're aware, I've got my phone now using the audio and the video. So can everybody hear me?
We can hear you.
Okay. So my name is Ben Oberbrockling. My major is engineering physics with emphasis in thermofluid and energy systems. And my submission for the competition this year is the Cool and Dry air cooler for use in dorm rooms, small spaces, and just general use for cooling a room. Next slide, please. So the problem is that AC is not available in lots of buildings, older buildings, typically workspaces, schools, apartments necessarily. And window units or other air coolers can be expensive, not necessarily very effective. They can be power consuming. So the problem is that it's not always convenient to get a cool cooling source in these scenarios. And so the market would be, I initially was considering for students living in the dorms here at Platteville. There's plenty of dorms that don't have AC, but that could also be extended to teachers in classrooms that don't have AC, office spaces in buildings that don't have AC, campers. So that would be like big hard side campers during the summer months. It tends to get warm, especially like at night if you're going to be camping maybe somewhere farther down south. And also elderly. Oftentimes, if there's going to be a heat wave coming through, you might just need a little more cooling, say, in your bedroom at night. And for this reason, a portable, compact AC unit might be of interest. Next slide, please. So the solution is the Cool and Dry air cooler, which uses dry ice as the cooling agent. And now dry ice poses some level of safe handling, but it's cheap. It's very efficient, actually. It stays very cold. Now the cooler itself, if you go down here, it's a very simple design. One inlet, one outlet. It really just pumps out the cool air via a fan over here. And so here's a quick demonstration. So currently our room is at 75 degrees. If I hold this down here, the temperature drops right away. So a lot of cooling power coming from this thing. As on the inside is full of dry ice, and it pumps up from this little fan here. That's good. And in addition, the the cooler itself is very compact, portable, as I mentioned before, lightweight, easy to move around from room to room, and it fits in a single room nicely. Next slide, please. So as far as current options go, they do sell air coolers, but the biggest problem with these, as you see on the slide there, is they oftentimes don't have the cooling power needed to, say, cool a big room, like say a classroom or an apartment, a whole apartment. So 45 square feet is not a very big room at all. That's a small bedroom, where say a dorm room is about 160 square feet. That's the square footage of the dorms in, say, Morrill Hall at Platteville, where I used to live, in fact. And so you need a little more cooling power. Next slide, please. Another option is window units. Now, these do cool a lot more, but they're way more expensive. They're bulky. They require installation. They're just way less convenient in general. This particular model on the screen was from Walmart, and it's one of the cheapest ones I could find, and it's still $100. So not near as cost-friendly as this, say, would be for minor applications for short-term use kind of thing. A window unit would be more of a permanent solution, and it might not even be necessary to have a year-round AC supply. Something like this, a more temporary solution, might be all you need, in which case it'd be more optimal to go with the cheap effect. Next slide, please. So some advantages, as I mentioned, it's cheaper than some air coolers, and definitely cheaper than the window units. And it's also more cooling power than most current cooler options. This particular fan puts out 31 cubic feet per minute. And I'll talk again about the dorm rooms in Morrill, where I used to live. So I got the dimensions. The typical dorm room in Morrill Hall is 1,300 cubic feet. Now, at 31 cubic feet per minute, that takes only 45 minutes to circulate all the air in the room, which I should mention, the dry ice in this cooler will last 24 hours at a minimum. So you would have more than enough time to cool the entire room several times over in the typical dorm room, at least in Morrill. And now there are bigger rooms, yes, but regardless, with 31 CFM, there's plenty of cooling power to be had to circulate a room. In addition, I mentioned that it's compact and portable, so the rough weight of this thing is about 20 pounds. So it's easy to transfer room to room. And something else is that it's quiet. Now, when I bought the fan, I did check the decibel rating, and it's rated at 25 decibels, which, for comparison, the typical box fan that you might buy, just the fan room, is 35 decibels. And those are not particularly loud, but you can hear them. Whereas this fan, I'm not sure how much you could hear it over the camera, but it's significantly quieter than, say, a box fan. So it really poses no distraction if you're going to be working in an office space, teaching in a classroom, et cetera, or sleeping. So for that reason, it's much more convenient. Next slide, please. So for future development, Ideally, I would get testing done, say in a dorm room or office space, a typical space of use, to really test and get some accurate, solid numbers as to how quickly it takes to cool down a room, for instance. Currently, I've only been just in my apartment here, so I haven't had an opportunity to, run just time it takes to cool down, say, I don't know, 20,000 square or 2,800 square feet. So that'd be a next step, is testing in these places. There's also further possibilities with the internal cooling system, which is essentially a set of piping that goes through, but that could be improved to increase the efficiency, and also actually the cooling power could be increased that way. And finally, partnerships. Now, the 3 examples listed on the screen there are Lifoam, Uline, and Igloo. They all make these coolers, which, by the way, I should mention, the cooler itself you can pick up at a gas station for $10, say. Now, next slide, please. The most exciting of these potential partnerships is with Igloo. One concern, which I thought I would highlight, is that this EPS styrofoam, which is what this is made of, is not particularly environmentally friendly. Well, Igloo has created what they call the Igloo Recool, which is essentially the same idea, a disposable, or at least a more temporary cooler, but it's biodegradable entirely. It offers competitive insulation, ability to EPS styrofoam. And it's the same price, if not cheaper. I looked at the website. You can buy one of those coolers that's on screen there for $10. And it would work, it's comparable in size. It's for the same application. It would be the exact same results with the earth-friendly aspect also included. And additionally, the cooler is just as durable. At least on the website, it mentioned that it was able to be taken, outdoors for several different uses. So it's temporary, or at least it's disposable, but it still gives you multiple uses. Next slide, please. Q&A.
Great, thank you, Ben. Judges, if you would, turn on your cameras and your audio. Any question, judges?
Ben, can you hear me?
Yeah, I can.
So I think I heard you say that the dry ice would last 24 hours.
Yep.
But is that with the fan running?
So yeah, so the general rule is that 5 pounds in a cooler will give you 18 to 24 hours, and there's about 20 pounds in here. So without doing a whole lot of precise calculations or testing, I figured multiplying roughly by 4 with a strong cooler and with the fan running. So I should mention before I go any further, the fan is not pumping out like carbon dioxide from the fan. There's a set of pipes internally that cool the air. So it's pumping out clean air for the most. I mean, there might be some leakage of, CO2 into the pipe, but for the most part, it's clean air. So the CO2 itself is not being pumped out. Obviously, still there will be thermal loss due to the warm air coming in. But yes, from rough estimations, you could say 24 hours should be a minimum of 20 pounds of dry ice lasting in this cooler.
Thank you.
Mm-hmm.
I have a question about, did you look at the dry ice supply industry, and is the capacity there for significant use for cooling?
Right. So that's a good question. Now, unfortunately, there's nobody in Platteville that supplies dry ice. I called around actually the other day, a few days ago, when I was looking to buy it. I know it's common, at least where I'm from, Sheboygan, Wisconsin. Grocery stores sell it, and there's other industrial supply companies that do. In fact, where I picked this up was the Hy-Vee in Dubuque. So I guess less convenient for Platteville students. I was unaware of that fact that nobody in Platteville sold it when I embarked on this project. So yeah, in Platteville itself, there's nobody that I called that sells it. That being said, most grocery stores, as far as I'm aware of, once again, where I'm from, it was commonly sold. So yeah, it is typically available in grocery stores.
Any other questions from our judges? All right. Well, thank you, Ben.
Yep, thank you.
Next, we have Zach Waters to present his prototype. Zach, you may begin once your slides are queued up.
All right. All right. So my main project for Hackathon is to develop a safe, efficient, and relatively inexpensive rocket engine for getting payloads into space, because there's currently the way we go about getting payloads in that into space is fairly expensive, since a lot of it is not reusable or has some pretty high costs that go along with reusing it. And the design I'm working on is supposed to cut down on some of these costs. You can go to the next slide. So the train of thought I'm trying to go along with this is similar to how we went from the steam engine to the internal combustion engines we have now, where originally we had a huge engine powered by wood and water, basically, and now we're to a fairly more compact design that runs off of corn sometimes, usually oil and that type of stuff. Yeah, there's just the past probably 100 or so years of internal combustion design. I want to apply that to rocket engines in a way. And you can go to the next slide. Sorry. The problem that I'm trying to solve is just being able to make that more compact and cutting down on the size of the engines and making it so we don't have to use staged launches, and we could have a single stage to orbit type of design, similar to a plane basically taking off and going into space from Earth. Yeah. Sorry. Can you go to the next slide? Wait, sorry, not yet. Actually, yeah, sorry. Yeah. The future development for this is basically, I do want to develop the entire vehicle itself, but you can't really develop a vehicle that would go into space without having a efficient engine that can get you there. There's a lot of other hurdles that I would have to go through to actually design a proper ship, but those aren't as big a hurdles as making sure that the way you get into space is sound and efficient. Sorry, yeah, can you go to the next slide? Basically, what I do need is funding for research and development to make sure that my ideas are viable and have a practical way to help get payloads or people, whatever the application may be, into space. There's the only real way to properly explore space would be to find a commercial application. Like there's way too many to get into, I would think, but can you go to the next slide? So what kind of qualifies me for this, you might be asking? Well, I've worked for the last 2.5 years at engineering place and assisting with all of the 3D modeling, talking with people on the floor, seeing what works and what doesn't. This is an example of some of the stuff I've modeled. Some of it has gotten fairly complex, and yeah, I've done a lot of work with engines themselves, with working on like cars, snowmobiles, that type of stuff. And as far as fabrication goes, I've also used a lot of fabrication processes to get to a point where stuff would work. So I do know my way around creating things. It would just be the research and development that would have to be completed to successfully achieve the end goal of getting payloads to space commercially. But you can go to the next slide. And that is there any questions you guys have?
All right, thanks, Zach. Yeah, judges, if you would turn on your cameras, and if you have any questions, please unmute yourself and ask Zach.
Zach, curious on your thoughts on delivering the amount of thrust needed for liftoff with an internal combustion engine concept.
Oh, sorry, it wouldn't exactly be the concept I have would be similar to like most chemical rockets. So it'd be basically just making it a plain configuration for stuff like the body. So the engine itself wouldn't have to produce as much thrust in the beginning of the flight. It would have to be more efficient throughout a longer flight, I guess, to like slowly ascend instead of using just a massive amount of fuel and air at the beginning, if that makes sense.
Okay. Sorry,
I guess I could have explained that better too. Sorry about that.
So I missed maybe at the beginning, but how much of this challenge of a rocket engine, a new rocket engine, is mechanical engineering, in terms of the engine itself, and how much of it is the chemistry or the fuel oxygen kind of issues?
Yeah, a lot of it, I would say it's kind of about 50-50, because you do need to have a good design for the chemicals to properly react and like produce the most amount of thrust between whatever your fuel and oxidizer is. So I know like companies such as like SpaceX are using like methane and oxygen together. Some rockets have used, I think it's hydrogen and oxygen together. So a lot of the mechanical engineering for this application would depend on the fuel that I would decide to use for the rocket. And currently I'm paying attention in my chemistry class so I can try to get a better grasp on how that fuel would need to be properly stored. Because I'd want to keep it in a liquid state, but I don't want to have to cool it down as much, since that's the issue with like, maybe not an issue, but one complication with a lot of fuels is like for oxygen, you need to have it liquid in a liquid state, usually for most engines, just to kind of base. But trying to find fuels that wouldn't need to be at freezing or below freezing temperatures to run through the engine.
Okay, well, thank you. You gave me a good sense with the 50-50 split there, so appreciate it.
Yeah, thank you for the questions.
All right, thank you, judges. Thank you, Zach. Next, we have William Hewson and Praise O'Bieliden to present their prototype. So William and Praise, you may begin once your slides are queued up.
Can you guys hear and see us?
We can hear you, but we lost.
We're going to be filming on Praises because we have a separate.
There it is. I got you.
Yes, you might have to pin us onto the side because otherwise I'll just show my name and not our face.
Okay.
All right. Y'all ready?
Yep.
All right. Hello, everyone. We're the team that design CycleSafe, bicycle signaling system. Before we get into our actual product, let me introduce the team. Please go to the next slide. I'm William Hewson. I'm in charge of electrical design. I also am in charge of marketing, and I assist the prototype construction. The partner here.
Hello, I'm Fraser Bialot, and I was the main software designer, CAD designer, as well as the prototype construction lead. Next slide, please.
First, we have an overview of what we do.
Next slide. So, what is CycleSafe? CycleSafe is an all-encompassing bicycle signaling system. It allows users to communicate with the road vehicle, with other road vehicles around them, such as cars. It gives these cyclists the same signals that cars would have, such as a headlight, brake light, and turn signals. It's powered by a rechargeable onboard battery, and it's we have a fully functional prototype to display here today. It's ready to sell. Next slide, please.
So the big question is, why would people need it? Well, cars have difficulty interpreting what bicyclists are doing. In any of the people we interpreted, they know about the hand signals that people have to signal, bicycles use to signal. No one actually knows what they mean. So this is a much simpler solution that cars can use to interpret the way that they interpret other cars. And this is especially useful seeing as almost 1,000 deaths occurred in 2019 due to traffic accidents between bicyclists and cars alone. In fact, the death rate is so high that I would assume that soon this will be a product that every bike will need, especially in big cities where the bicyclists are on the rise. Next slide, please. Next slide.
So, how do you use this product? So, here we have our demonstration battery. When you plug the battery in, the system automatically turns on and the backlight begins to flash right here. So then we have a button here, a locking push button. You press the button once to turn the headlight on, and then you once again turn it off. And here we have a momentary button. That's we're using a limit switch for demonstration purposes. In the actual final product, it will be attached to the bicycle's brake levers. So when you pull the brake light will turn on and stay on for as long as the brake is pulled. When the brake is released, the light will turn off, just like in a automotive vehicle. And then here, we have a three-way switch that when pushed to the left will turn on left turn signals, when pushed to the right will turn on the right turn signals. And in the middle position, the signals will both be off. These can be mounted on anywhere on the bike for ergonomic purposes, so you can be able to reach it with your thumb or your finger if necessary. And all that is powered by the Arduino Nano here. That is the main logic section of the board.
Next slide, please. So the big question here is, who would buy it? Well, our major market is parents. Parents clearly love their children dearly, and they would be willing to pay a lot for, basic safety purposes. Now, of course, a lot of parents don't really want their kids driving on roads yet. But the nice thing is that this doesn't just have turn signals. It's got a headlight and a backlight too. So as the child grows, this is still useful as they go onto roads, but before they grow, you still need a backlight and a headlight in case they're driving at dark or just in low light areas. Another main area is big city populations. Big cities and urban populations have seen a drastic rise in bicycle use over the years. And with that means bicyclists are going to be sharing the road more with cars. So bicyclists are going to need to be able to signal to other cars to show what they're doing, especially in a city where there's lots of weird turns everywhere. And finally, our final major market is college students. Bikes have also started becoming quite common on college campuses, along with cars, as people need to get around places. This is another situation where being able to signal where you want to go or what you want to do to the cars around you is going to be incredibly helpful in avoiding accidents. Next slide, please.
So where would a product like this be sold? I envision this product being sold in places, in supermarkets like Walmart and Target that already sell bikes. So a product like this would be in the same section as the bicycles, so that potential customers for bicycles would also see this as well and maybe grab the products. Another location it can be sold is bike shops, because generally professional cyclists do not shop for their bicycles at supermarkets like Walmart. They go to specialized bike shops or maybe shop online or repair shops. So there, the product will also be exposed to professional cyclists as well as just general cyclists who might be interested in a product like this. Next slide, please.
We'd like to get into a little bit more of the technical aspects of how it works. Next slide, please. The first big deal, but the big part of it is the brain here, the Arduino Nano. displays is showing here. The Arduino Nano is the logic board of the entire prototype. It controls the speed of the blinking, what blinks, where it blinks. It does pretty much everything. We use our Nano because it's incredibly adjustable. Maybe the blink is a little bit too fast, we can turn it down in software. Maybe the blink is on too long, so we can turn it down in software. But the nice thing is that this can be replaced with discrete components and gates, or even just straight up discrete components later on and down the line if we want to lower the cost even more. The Nano is located in the same box as the power supply and the transistor protection circuit, which we'll be going into later on. Next slide, please.
So here are the LED modules. They consist of 18 LEDs each. They're in the back, we have 4 LEDs, 4 red LEDs dedicated to the flashing backlight, 4 more LEDs, also red, dedicated to the brake lights, and then 20 LEDs for the turn signals, 10 on each side. In the front, we have a similar setup for the turn signals, but the headlights instead, the 8 LEDs are all white and they all connected together to work as one for the headlight because this is required to be pretty bright. And the LEDs can be changed in the future if brightness needs change. Next slide, please.
And this we see on stream is the transistor protection circuit. It's dangerous or even it's unhealthy or even dangerous to run your load of this scenario, the LEDs, off of your logic. So what these do is they separate the two systems while still allowing the Nano to control the LEDs. This also serves a dual purpose where I use B2T's transistors and they allow the transistors to pull an exact amount of current through itself through the LEDs. LEDs require around a little bit less than 20 milliamps to power. And these make sure that each system of LEDs gets the exact current load that it needs. It is also located on the same board as the Nano, which you can see right there. And it's mainly due for a safety feature. Next slide, please. Where we'd like to spend a little bit of time talking about the market research we've done. Next slide, please.
So here are 2 images of our main competitors we found on the internet. The one on the left is a brand called Vasfire. It's similar to the back end of our product here. It has a brake light in the middle and turn signals on either side and has a wireless remote that will be mounted somewhere on the handlebars for easy access. On the right-hand side, what I believe is MyLAN. That's a little more advanced than the one on the left. It's similar. The one on the left in the same sense that it has the same turn signals and brake light. Actually, not brake light. Flashing backlights to alert drivers that there's a bicycle there. But in addition to those 3, it also has lasers that it focuses on the ground to make like a virtual lane around the bicycle for other road users to see. Next slide, please.
So the major advantages our product has over our competitors is that it is an all-inclusive safety system. Other than a helmet, no other products are really required. It's got a headlight for seeing in the dark. It's got a backlight so drivers behind you know where you are. It's got a brake light to know when you're braking, latch and turn signals, know when you're turning. Nothing else is really necessary, you know? It's another good point is that it's all powered from the same source, this single battery. Those other 2 systems have 2 points of failure. If your battery in the remote runs out, you can't control your backlight. If the battery in the backlight runs out, there's nothing to control. For us, there's one battery. If it's going to fail, it's going to fail all at the same time. You're not going to have 2 separate things that could either fail one or the other time that break the system. Excuse us for a second. We've got a phone issue. All right, we're good. One of the often overlooked advantages is that these are positioned ergonomically on the bicycle. You don't want to be reaching all across the bike to find something when you only have one hand to steer while you're going fast, while there's a car behind you wondering what the heck you're doing. These can be positioned wherever you want them, and to them that can serve the most comfort to whoever is driving. And the big advantage is cost. This can be produced, next slide, please. You can see here an itemized list of all the different components and their costs. We can produce this at cost for only $10. Really distracting. For only $10, $11 can round up. This means we can sell it for around $20 and make a pretty hefty profit comparatively to, what is with that? Sorry, we're using a weird setup with Praise's phone recording us, and it is freaking out right now for some reason. You good? Okay, I'll keep talking. So we can produce this for maybe $20 or even less if need be, which means we easily undercut our competitors. My LAN, $50, hard limit. The Vastfire, $25. And even then, it's not a great difference, but it's still $5 lower, and it offers more to it. Next slide, please. Speaking of pricing, we've decided to talk about, we've decided to price this at $20 per unit, as I said before, which is lower than our competitors while selling more functionality. And again, as I mentioned before, it gets cheaper if we use discrete parts. Next slide, please. Our timeline is, I'm just keep talking while Praise tries to fix our problem. Our timeline here is, our prototype is fully functional. It does everything it needs to be. We just need the attachments. And with the Arduino, it's easily adjustable depending on what people want. The problem is that resources and skills that me and Praise don't have are required to put this out to market. So our plan here is to sell it to the highest bidder. And we're going to we're going to patent it and sell it off so that they can get out to market so that we can worry about it less. Next slide, please. That is all we have for you today. If you have any questions, please ask us. You good? It just work now? Oh, what the?
That's okay.
Is
thank you, Praise. Thank you, William. Judges, if you could turn on your cameras if you have questions.
Do you just want to run up there and yell at him? Like, a friend of ours is trying to spam call Praise. Well, Praise will deal. I can answer questions for now.
So I'm intrigued with the brake light because I'm not that familiar with that. How would that work? That wouldn't work off of the same control as the signals, would it?
No, it is a limit switch that we would position right below the brake signal. So when you press the brake, it automatically triggers the brake light in the code.
Okay, so you'd have two of them for the front and the back brake.
Yes. Well, no, actually, you just need one switch underneath one under one brake pull, and it'll automatically trigger itself.
Okay.
So, yeah.
Great.
We could add a second one if people only use one brake, but if you use one brake, you're going to go flying over your handlebar. So
I was taught to always apply your rear brake first, and then maybe if you need it, apply the front brake.
Interesting. We could again, the nice thing about this is it's so adjustable. We could just move this to the rear brake, and then since everyone uses the rear brake first, easy, you know?
Great, thank you.
Any further questions?
Okay, great. Thank you again, William and Praise.
Thanks.
Thank you.
All right, Next, we have Jacob Ubel, Matthew Nye, and Luke Behan to present their prototype. You all may begin once your slides are queued up.
Hello and welcome to our presentation today about our product Aurora Scrub. My name is Jacob Ubel.
I'm Luke Behan. And I'm Matthew Nye.
And we'll be cleaning long after you're done. If you could click the next slide for us, please. Have you ever let the kids do the dishes in the sink at home and they wash the utensils, scrub them all up, or barely touch them at all with the soap and water and take care of the dishes by barely blowing them off and scrubbing them down with a hose? And you let them put them away in the dish rack to wash them again later or stack back in the closet because you just can't tell them they didn't clean it right and don't want to diminish their spirits about having done the nightly chores. Have you also noticed that in your community supply space, while you're away from home, all of those shared communal office supplies aren't cleaned by anyone? Those products often go from one office to the next, carrying with them the diseases and germs that may be on them from whichever coworker you had that used them last. They then make their way back into the community office supply cabinet or back into the printer room where they sit and wait to go again through the office, carrying with them all of the timeless travels that they have gathered from their office hopping throughout the building. The solution to both of these problems in sanitizing and cleaning these products is Aurora Clean. If you want to click the next slide for us.
So our product is a UVC light system that can be installed in drawers that can be installed in any drawer. It functions as soon as the drawer closes. And if you want to start the video, I will discuss this demonstration. So you can see it only turns on when you shut the drawer. And in order to make sure that you have no UVC light that you're exposed to while the drawer is open, it turns off as soon as you open the drawer, like I showed right away. Then when you shut the drawer, it runs for a 5 to 10 minute times. So that way it will disinfect everything that has been placed in the drawer. This demonstration only shows it for 30 seconds due to the nature of the video. Another feature is there was a red LED placed with the system, which would indicate when the system is on, because UVC light is outside of the visible spectrum and you would not be able to see it working. It can be used as an indication to know that it's working, or just as a safety feature to make sure that you don't put your hand in there when the UVC lights are on. Next slide.
Again, it has UVC lights that are proven to kill viruses and bacteria. It is also has a built-in timer, so when the drawer closes, it turns on the UVC for an amount of time to ensure that the items are clean. Also, the unit has a rechargeable battery to make it easy to install without putting any holes in any existing drawers. There's a red LED light to indicate that it's powered on. This system is meant to be a one-size-fits-all, where you get an LED strip to wrap back and forth through your drawer until it fits. Next slide, please.
So our market potential and target consumer for this product is starting small, getting ourselves in one business that has expandable growth potential within their company and their parent industries. A good example of this is Georgia-Pacific, who has countries and plants and office buildings all over the world and our nation. They also have a parent company, Koch Industries, which would then allow us to expand into larger companies and sister products along with this organization. Our idea being is that once we get into one of their office buildings and show them that our product not only limits sick days that employees take, but also stops spreading diseases within the workplace, that they will then expand it within their own company until we've grown within their industry and their parent industry. By then, we hope that word of mouth will pass through as people begin to visit these industries and see these lights working and hear about the phenomenal loss of sick days and health issues associated with office cleanliness that have become an all-time low within the company. We'll then grow to expand into more offices, industries, and companies. And from there, we'd like to go directly to an office supplier. Our intention being that if we sell this product to the manufacturer of office desks and office equipment, it can come pre-installed for you and have your system and product work flawlessly every time with the desk built in. We also would like, once we're done in the commercial industry and selling directly to office suppliers, to move into the residential area. As we'd addressed earlier, the idea of cleaning your forks and silverwares and plates and items of that nature that may not have been fully sanitized when you let your kids do the dishes can now be sanitized and cleaned far better than you had ever dreamed by putting one of these systems in your own home or light cabinet. We would sell directly then to the residential user in your average Walmart, Target, or other local supply store, advertising the fact that this cleans when you no longer are. Another potential marketing opportunity for our team is the current COVID-19 global climate. In the experience right now, all companies and businesses and opportunities existent in the world are focusing on how to adapt to the changing environment as created by SARS-CoV-19. Our product has been proven, as we'll explain in a little bit, that it has destroyed and helped prevent the spread of SARS-CoV-19 within hospitals and working environments. Within this global rise in the COVID pandemic, we've seen a lot of shift towards office sanitation and sanitation in industries that have never seen it before, such as planes, movie theaters, and things of that nature. Right now, in this global climate, is the perfect time for the launch of our product that will stay in and help stop any future diseases from breaking out. If you'd like to click the next slide, please. So we've now proven that we can sell our product, but if we can sell it, how do we make money? Right now, our targeted selling price for our consumer is around $50, with this price getting cheaper dependent on how many they order or how many office buildings they would like to supply it in. And our production cost will be anywhere from $15 to $20. These prices vary, as right now, UVC lights in small quantities are very expensive. If we're allowed to buy in bulk and purchase more product and more plastic pieces and involve our own manufacturing assembly system, it will keep our costs down and allow us to raise that selling point or potentially our production costs. We would also like that once we get into the consumer real estate, selling direct to office suppliers, that we can offer them an even lower price as they then sell it in every desk they sell as a standard issue feature, much like one often finds nowadays in sunroofs in cars. So the more money that we are allotted to pursue, the more money that we're allotted to pursue further profitable applications, which will then allow us to branch into the residential real estates and areas of that nature. If you'd like to click the next slide, please.
There has been extensive research done on how UVC lights can be used in germicidal applications. And in that research, they have found that it is effective at neutralizing and killing viruses and bacteria, including SARS coronavirus. And furthermore, they believe then and are testing its ability to kill SARS-CoV-2, which is the reason why we're all currently in a pandemic. UVC lights are currently used in hospitals to disinfect rooms, and there's further research being done on the applications of UVC technology in airplanes. So that way, after large groups of people are congested in one location, the area can be disinfected for the next group of people. Next slide.
So there is some competition. There's already a few products on the market that utilize UVC lights, one of them being a sterilization cabinet that you would need to have a dedicated location at a workplace, and that's not optimal for all work environments. Another one is a UVC drawer that's a standalone unit that would have to sit on a drawer, but the only downside with one of those is the fact that you have to put one item in, it sanitizes, then you take it out and put it back in the communal drawer. That basically negates the whole process of cleaning it with the light. So we feel as if that one would not be beneficial in a work environment. The last one is a LED strip that you mount inside of a drawer, but that one you have to turn on manually with a switch on and off, and you're exposed to these very dangerous lights that are not supposed to be exposed to you. Next slide, please. Some frequently asked questions we thought people would ask is, how easy is it to install? Well, our idea was to have a 3D or 3M tape adhesive on the back that make it easy to install. And you just leave it. It's a one size fit all, as we said. Basically, you wind the strip back and forth to fit your drawer. And what about stacked objects? Well, the idea behind our product is that the intensity of the light and the reflection off other objects will kill any existing viruses and bacteria. We've also had the idea of having a partner product that will have, that's basically a riser to kill all the bacteria that's there. And we have to still see how effective it will be, but it's an option. Next slide, please. Thank you guys for your time. Do you have any questions?
All right, thank you, Jacob, Matthew, and Luke. I'll turn it over to our judges. Do you have any questions?
You know, I want to apologize. I was distracted the first minute, so I may have missed this, but do you have a prototype of your light? And if so, can one of you show it up again?
Yeah, if that would actually be on Tony if he could reshare that slide of our presentation. We had a video of it operating within our presentation.
I'm sorry. I missed that. I heard that in the background, but I missed it. Don't go back to it, Tony or Mike. Thank you.
Do you have any concerns on, like, or how are you addressing shadowing? So one of the big concerns with UVC, right, is it has to actually strike the virus to kill it. And so if there's multiple objects in a drawer, one object will likely shadow the other. How have you thought about addressing those types of issues?
And that's the goal why we're using like an LED strip, which has multiple lights on it. The multitude of lights will cast multiple different aspects of light. So you wouldn't have to worry about one object shadowing another one. It'll be coming with angle from all the different angles. And if you have a high enough intensity, the light will reflect off of other objects, and then it can still kill the virus.
We had also addressed the idea of, as Luke had mentioned briefly, a sister product for residential applications holding plates stacked individually to allow all of that surface area to then be exposed. and potentially installing a covered application, in which we had also looked at potentially addressing, where the light application wrapped from the doorway onto the sides of the paneling, in a covered application instead of a drawer where it's covering from the top. In a cupboard, it could come from all sides and allow for that kind of wrapping effect to stop shadowing from occurring and getting the light to be a really encompassing aspect of the drawer or cabinet.
Thank you.
Is there one other question out there from one of the judges? Okay. Well, thank you again, Jacob, Luke, and Matthew. All right, finally, we have Evan Tenney to present his prototype. So Evan, you may begin once your slides are queued up.
Good afternoon. My name is Evan Tenney, and I'm here to tell you about my product, GoBoard. I'll start out by telling you a little bit about myself. I'm a mechanical engineer major, sophomore at UW-Platteville, and I'm constantly working on some sort of project, whether it's building an electric bike in my dorm room freshman year to building a CNC router in my dorm room last semester. And the newly built CNC router is actually partly how I came up with this GoBoard project. So in high school, I would snowboard with some of my friends during the winter, but then in college, none of my friends at the time snowboarded. So I didn't want to drive hill, pay for a lift ticket, and I didn't want to go to a ski hill, pay for a lift ticket, and snowboard all day alone. So the inspiration came from this for both wanting a project to try on my CNC router and thinking how I could snowboard on local walking paths and parks without the need for a ski lift. And I started working on this project in late January of this year, just for fun. But then once I began testing it, it worked a lot better than I expected. And so because of that, I thought there might be more to this project than just for fun. Next slide, please. Problem in marketing. My problem statement is there currently isn't a way to snowboard wherever you want without the use of a secondary vehicle in a compact size. The GoBoard would be marketed as a recreational vehicle for recreational riders. This market would be very similar to the existing electric skateboard market. I estimated the market size for this GoBoard to be roughly around $200 million. This estimate comes from the following information that takes the size percentage of the electric skateboard market and applies it to the size of the entire ski and snowboard market in the US. Next slide, please. Solution and benefits. My solution to the previously stated problem is a self-propelled snowboard that users can ride on various terrains. The benefits being that you can snowboard without the need to drive to a ski hill, therefore you also don't need to pay for a pass. You're able to ride solo without the need for anyone else, and the entire system can be carried by a single individual. The GoBoard is relatively compact and fits in the back of a car. This is my personal opinion. I feel that it's safer than motorized skateboards since you're falling into snow rather than concrete if you do end up falling. And then lastly, the motorized portion can actually be removed, and then you can use the snowboard itself as a normal snowboard at a ski hill. And I have already tested this. Next slide, please. Competition and advantages. When looking at possible competition, the closest product being manufactured are these gas-powered snowboards you see up at the top. There are a few people who have also made videos on their motorizations of snowboards. However, they haven't developed their ideas into a product. The bottom design was published in 2013 and most closely resembles my product, but again, this has not gone into production and is still functionally different from my design. The advantages that my solution has over these examples is that users can ride the GoBoard in almost every way as a traditional snowboard. It's suitable for various snow conditions and going up hills. Lastly, The Go board provides sporty performance and speed in a compact solution. Next slide, please. Future development. When looking at future development from my prototype, here are some of the items that I've already started working on. First of all, the track is too stiff and it's wasting a lot of power in my design. I also like to look at various tread patterns to see what would work best for the wide variety of snow conditions that you can get. Currently, the batteries are worn on the individual's back, but I believe that those can be moved to the board for a completely wireless experience. The design can be made lighter through optimizing materials and through the use of a hub motor. I currently have a prototype for the suspension system that I would like to incorporate into the next version. However, since this is a fundamental aspect of my design, I won't be sharing how that works with you, but I will show you a demonstration later on. This is a recreational vehicle. However, this next possibility could increase the market size. There have been numerous occasions where just riding around campus on my bike during this winter months, I've fallen. So if people rely on bicycles as their daily commute, if the range for this is good, it could potentially go from a nice to have to a need to have daily commute vehicle for some individuals. Below, I have put together a list of potential collaborators along with how important a partnership with these companies would be. Overall, I think having a dedicated company to manufacturing the rubber tracks is the most important to me at this point, since I can then base designs around that without having to build my product around pre-existing solutions, such as the track I'm currently using. Next slide, please. Thank you for your time, and I'll open it up to the floor for any questions. I do have a following slide after this one demonstrating the prototype if you would like to come back to questions after viewing the demonstration. I believe the top video is it's the newest or the latest one since there was snow for testing out. Then I'll just add that the second video is just showing that it works on a different snow terrain as well. So the first video was deeper snow, whereas the second video is more of a compact, flat snow.
Okay, thank you, Evan. Judges, if you would, turn on your cameras and please proceed with any questions you might have.
I'm going to jump in here and ask you right away, Evan, if you've considered how global warming might impact this, the demand and the opportunity to use this product.
That's a very good question. I actually have not thought about the global warming aspect, and that you'd have to go farther up north to even use this product as it becomes worse and worse. So that is definitely a good point that I have not thought about. Hopefully we won't have to think about it.
Well, I can tell you as a cross-country skier for 30 plus years that it's a concern. Even in Wisconsin, the winter environment is not as predictable as one would hope.
Right. Thank you for the question.
Evan, I'm wondering if what the capabilities are for speed control. Do you have different speeds on it, or is it just kind of a one set system?
Nope. So right here, this is the throttle right now, and it's a variable speed. So the speed is completely adjustable based on how far you pull the trigger.
All right.
How long of a ride duration are you able to get?
So I had, the problem is before I had this sticking through the bottom a lot more, so it was really hard to balance. And by the time I finally got it to a point where I could ride it, there wasn't any snow on the ground, so I don't have a good estimate for ride time. And also because this track is so stiff, in the video you saw how fast I was going. It's supposed to be 3 times faster than that. So this track, because it's so stiff, is taking a lot of the power away. And so because of that, I didn't want to put a range estimate on it yet, because it's using up all the power that the system can give it. So
Okay, thank you.
Right now, there's not a number on that.
Good answer, thank you.
All right, thank you, judges, and thank you, Evan.
Any other questions?
I think that's it.
Okay.
Okay, well, that concludes our student presentations for this afternoon. Fantastic job to all of you. Judges, at this time, please ensure your audio and video are turned off. Then call into the conference line to begin your deliberations for awards. Now, while our judges deliberate, I'd like to welcome Dr. Philip Parker, Associate Dean and Professor for the College of EMS. For those of our attendees who are not aware, UW-Platteville is currently constructing Sesquicentennial Hall, which will include a state-of-the-art innovation center. So of course, what better place to learn more about UW-Platteville's newest learning, innovation, and prototyping resource than during the Prototype Hackathon. Thank you for joining us, Dr. Parker. We look forward to learning more about the ongoing project.
Thank you, Tony. I just want to see if I can use my laser point, annotate with a laser pointer here. It looks like it's not going to give me that option. Okay, well, yeah, so as Tony said, my name is Philip Parker, and I am a faculty member and an associate dean in the College of EMS. And are you advancing slides for me, Tony? Is that right? Thank you. So this photo is from our construction camera that is on the top wall of the football stadium. And so you can see every 10 minutes, a new photo is up there. So this is the one I downloaded yesterday. And if some of you aren't on campus, it sounds like, so this is what's happening, and it's a lot is happening. It's happening really quickly. It's exciting to see, as you can see on the second floor there, they're starting to put the sheathing in, or I'm not sure what it's called, the corrugated metal anyway, that they'll pour the concrete over for the floor. So it's going really rapidly now. It's very exciting to see. Next slide, please. 2 Saturdays ago, I flew my drone and took a composite image of the site. And so that's what it looked like 2 weeks ago. What I want to point out, and if I have my laser pointer, you can't see my, but how am I going to do this? Well, first of all, we have Engineering Hall. That's not obvious. It's a completed building, or Busby Hall as we're calling it now. And the football stadium is kitty corner diagonally across the road. And then where you see the only curved wall on this place, kind of in the jutting out into the parking lot there, is kind of a marker that'll help us orient ourselves as we look at some pictures later on, because the only curved wall. Tony, are you able to point to that? Do you know what I'm talking about? Can you see that? Thank you. Oh, that makes me feel better. Okay. So that'll orient you as we look at later photos and later renderings. Next slide, please. And this one also helps. This was 4 weeks ago, and that's how quickly this might have been 5 weeks ago, but that's how quickly it's going. This is just showing the foundation, and then I overlaid on that some of the exciting spaces on that, what would be on the first floor. And pertinent to you all today is the Makerspace, or we're also calling it the Innovation Center. Again, that's why I was pointing out that curved wall, because we'll be spending a bit of time there today. It is 2 floors, and I'll be showing you some pictures there. It's important for, if most of you know our campus, perhaps, again, Engineering Hall or Busby Hall, in the southwest corner of that building is where our student organizations hang out, SAE, ASCE, for the concrete canoe and the steel bridge and the mini Baja and so forth. Different organizations are in there, and that will be connected to this. And I'll try to remember to point that out later. So it's going to be large. Altogether, it'll be about 20,000 square feet. So very exciting. And again, scheduled to open up fall 2022. There's a tiny chance, there is a chance, very tiny, but a chance that we could even have Hackathon there next April. I mean, but that's pretty slim. But 2 years from now, we'll be there. Next slide, please. So what I want to do is to take a little tour, and if you see, so again, to the right is Busby Hall, existing Busby Hall, and to the left is Sesquicentennial Hall. And you can see where the people are on the left-hand side, and there's doors there, right to the left of the silver letter Sesquicentennial Hall. We're going to go in those doors now, please. And you walk in, and to your right will be a welcoming face, which will be great for visitors. But you all are going to be captivated by what you see all over to your left. Is that you see that orange horizontal thing? That's actually, we're looking in the Innovation Center, the Makerspace there, and that's the bridge crane that we'll see a little bit of later. So, and now we're going to continue to walk back, please, Tony. Or actually, we just kind of shuffled over to our left a little bit, I should say, to get a better view. And these rendering, if you're really eagle-eyed, you'll notice that the information thing on the right changed. So these renderings are from different generations of the design process, but it's virtually the same. So straight, but again, very purposeful. And hats off to our dean here, Dean Molly Gribb, because she was one of the visionaries from the start that said, we've got to have a makerspace, it's got to be huge, and it's got to be visible when you come in the door. And that's exactly what we're going to have. So you're going to walk in and you're going to say, wow, what is that straight ahead? So we're going to go straight ahead, Tony. And so we can look down, and again, there's that orange beam on the top that represents part of the bridge crane. You'll be able to look down inside. We'll look at what's going to be there in a minute. But where that fellow was walking away from us, we're going to follow him. And Tony, next slide. We're going to go in those doors right to his right. And this doesn't, I think that might be the same guy on the left. I don't know if he turned around. But anyway, we're going to go in, and kind of where we're standing here will be the welcome desk again. It's about making, we're going to talk about this a little bit later, making everyone feel welcome. And so people will be greeted and welcomed. And so in the foreground, we see an open area for tinkering. There'll be drop-down power, not shown. And in the background, you see there are 3 different design studios. So great conference meeting, small meeting rooms for you to talk in private if you want, with video with computers, monitors, and of course a webcam, so we can Zoom in the future. Continue on, please, Tony. Kind of wandering around this first floor, there's a space for sewing and photography, and again, looking down in those white squares, just being stand-in for the machinery that's going to be there. And the same thing on the right behind the woman in the purple is just some placeholders. This will be there'll be vinyl cutter sewing, and on this floor will also be a photography area. Next slide, please. Lots of natural light too. Can you imagine? It's going to be an awesome. It's going to be. It better be a magnet. It's going to be. I hope this place has hundreds of well, maybe not all at one time, but dozens and dozens of people at any time working on things. So again, and then straight ahead, through those windows straight ahead is existing Busby Hall, just to kind of help you orient yourselves. Okay, next slide. So now what I wanted to do here is to walk around in plan view to show you a little bit better what we have here. And again, to orient yourselves, upper left-hand corner, there's that curved wall again. So where it says reception, and those arrows somehow got a little bit messed up. But right where it says above the word reception is that doorway we're going to enter in. There's a reception area. We're also going to have some checkout up here if you need a toolbox of some standard tools or maybe some materials up here for the 3D printers, for example, because the 3D printers will be up here. So I'm going to walk around clockwise, and then the open workspace we saw in that really nice rendering where we walk in. I already talked about the design. So nothing I haven't talked about here yet. Excuse me, everything here I think I've talked about. I'd like to point out on the upper right-hand corner, the videography photography room. And that was, by the way, we toured several universities, maker spaces, including UW-Madison's, to learn more about best practices. And one thing that stood out, I think, was at UW-Madison, we saw this, was they had a room dedicated to photography and videography. The idea being you've got that go board or that braking system for your bike, that light system for your bike. And instead of propping it up on your kitchen table or your bed in your dorm room and taking a picture with your phone, you're going to bring it in here and have the backdrop, have the lighting just the way it needs to be. And you're going to take an awesome photograph of that. Or if you need to record in quiet and with the proper lighting, if you need to record a presentation, this will be the place to do it. Next slide, please. Stop. Okay, that's fine. In the bottom, you see the stairs. So we're going to walk down the stairs now, and we're going to pop out on those stairs in the lower level. Thanks. And so right in that vicinity will be soldering and electronics area. But again, you're going to walk down here in the shop supervisor offices to the right. Currently, that would be if you know Kelly Tollison or Kelly Tollison works in the EGH, the Busby shops currently, or Jeff Steiner in the OTS shop. They'll be sharing this office, and then again, and to the left, the tool crib. So more place for you to check out equipment. Also, there'll be a swipe on the door because now you're entering into a little bit more dangerous area in terms of the type of equipment. So there'll be a card swipe for you to enter in, and you only get to go in if you have the appropriate safety training completed. Because down here is where you have the metal lathes, the drill presses, the mills, bandsaws, etc. And we just don't want anyone coming down here and wandering around. So this will be a little bit more secure. You have to go in only with proper training. Top of the screen, material storage is just what it says, but there'll be a loading area there too. So right convenient there will be to any sheet goods or any materials. A lot of materials, large materials can be stored there. One thing I'm really proud of and that we're very intentional about is upper right-hand corner to have a room for recycled parts. Let's suppose some of you folks, let's suppose you're doing your snowboard there or your ultraviolet light sanitation system, and you have a couple extra light strips left over or a couple extra motors left over, and you're graduating, you say, here, you guys can have it. Instead of just putting it in a big box, a bin somewhere and people sorting through it after the fact, we will have an inventoried system here that will be for free, right? That you can say, do you have any stepper motors or do you have any leftover UV strip lights or whatever? And again, we have companies like Train Corporation send us a couple of pallets full of parts that they were done with, that they had used in their makerspace. And so really excited about that. Again, a way to support our students with low cost or free items. And then if you walk past the recycled parts, again, just to orient yourselves, you're walking into our existing shop area where welding will remain there and the wood shop will remain there. Next slide, please. So a group of us, including Jonas, who I see is on this call, have spent some time over the last Jonas just more recently, but year and a half to be pretty intentional about how this area will be used and what is the whole point of it. So we have a mission statement, which I think is really important place to start. And I won't read them, but maybe I'll highlight some points. And the number one, that all users will feel welcome to participate, right? So not just people who look like me, and not just people like me who grew up in the country and grew up with a dad who was always fixing things, right? So I would feel pretty comfortable coming in here, I think, as an 18-year-old. But we want this to be that everyone feels welcome and everyone feels at home coming in here to work. Again, you've probably read these all, but maybe the last item to emphasize that, oh yes, it's for you students, but also we hope our staff will use it for their own entrepreneurial ventures, as well as, of course, for their classes. And then, yes, the community, please. Let's welcome them in. Next slide, please. So we came up with some values. Also, along with our mission statement, and I guess I should say who is. This is our current shop people. This is me, Dr. Jody Procyse, who is one of the judges, I believe, here today. Our mechanical engineer, she's our mechanical engineering chair. Tammy Salma Stevens, some of you know her. She runs our student success programs. Dr. Jessica Fick in mechanical engineering. So a range of people, and to talk about, what do we want this? And these words are going to be front and center. When you come in, you're going to say, welcome. Oh, by the way, we value diversity and inclusion, and that will be likely the first one you get hit between the eyes with. And we do value a growth mindset. The idea that you come in and that even if you are someone like one of you guys that clearly are very talented, and I tip my hat to you. I'm proud of myself when I change the brakes in my truck, and you folks are so far advanced. But even you all, when you come in, that you're going to have a growth mindset. And again, the cross-disciplinary collaboration, big ideas. And thanks, Molly, for that. I see that chat comment, and that is, I think it was, I hope it was it is in our mission statement, right? But we're being very careful. This is not the College of Engineering's Makerspace or Innovation Center. This is UW-Platteville's Innovation Center. And then the last slide, please, is simply to, so again, Dr. Procyse and I and Dr. Dean Gribb and others have been working with different, like WEDC is funding us for some things to promote and to build out our innovation center. But we're finding there's a lot out there to support rural technical entrepreneurship. And UW-Platteville over to the right is just one of those pieces, right? So yeah, we're awesome at curriculum and coursework. We're awesome at Innovation Center Makerspaces. This is going to be one of the largest, if not the largest, in the upper Midwest. And so that's us, but we have this thing called Idea Hub that's just getting off the ground, that is being funded by the U.S. Economic Development Agency, again, to help local rural entrepreneurs that say, I got this idea and I think it could turn into something. Where do I start? And one place they might start will be downtown Platteville at the Idea Hub. Of course, the community, and not just Platteville, but Dubuque and other communities have, often have some sort of business incubators and co-working spaces. And then WiSys, our awesome sponsor of this event today, and their all of the services they provide. So we're starting to sort this out now as we think of our role, our being the innovation center in this case role. There's some overlap, and so we are working on that. Just how do we help to clarify the landscape, the ecosystem, as they say, for regional entrepreneurs. And so I just put this last slide that obviously I'm pretty excited and I'm bragging a lot about our innovation center, but I recognize that this is just one piece of the puzzle to help people become successful with their ventures. So thank you for listening. And if we have questions, Tony, it'd be great, but maybe the judges are back and maybe it's time to find out who won. So.
Thank you again, Dr. Parker. Yeah, it's all very exciting, and absolutely we're looking forward to a future prototype hackathon making use of that space. If there are any attendees today who would like to learn more, I encourage you to head to the UW-Platteville website. There's more information there. You can see current progress, or feel free to reach out to Dr. Parker via email. That's parkerp@uwplatt.edu. Okay, so as our judges finish up their discussion, I would like to acknowledge a few more key supporters and our sponsors for this event. So first, I'd like to acknowledge and thank Dr. Hal Evanson, UW-Platteville Professor of Engineering Physics. He helped champion this event on campus and make this year's competition a success. I'd also like to acknowledge Dr. George Kruger, Professor of Marketing at UW-Platteville, Drew Brogue, President of the UW-Platteville American Marketing Association, and the other UW-Platteville AMA student members. Together, this group provided marketing advice to the teams today, so they may better understand their target market and where their product would fit into the commercial landscape. This support has become crucial to the Prototype Hackathon and the teams competing, so we greatly appreciate your efforts this year. Now, finally, I'd like to welcome our award sponsors to say a few words on behalf of their organizations. First, sponsoring our third place $250 award, I'd like to welcome Wayne Wodarts, Director of the Platteville Regional Chamber.
Thank you, Tony. I'm relatively new to this position here with the Platteville Regional Chamber, and I believe this is would be the third year we've participated at least. I don't know how we got involved in this, but I think it's a wonderful collaboration. Our organization collaborates a lot with the University of Wisconsin-Platteville. We have many faculty and staff over there that participate in a lot of our programming. So it's just another great way to partner. I think this is a wonderful activity that we're showcasing talents of the students at the university here in an entrepreneurial spirit. And that's what we're all about, is creating ways and means for students to succeed. And what a great way to for us to spend time together to give this opportunity to those that need it the most. So thank you.
Great, thank you, Wayne. I'll just make one clarification there. The Chamber has been involved in this event since the very beginning, so now all 5 years. Okay, next, sponsoring our second place $500 award, I'd like to welcome Will Hoyer, Director of the UW-Platteville Office of Research and Sponsored Programs, to say a few words about the ORSP and the Student Research and Engagement Fund.
Sure. Thanks, Tony. Like Tony said, I'm the director of our Office of Research and Sponsored Programs, and manage our Student Research and Engagement Fund, which is student money that comes into campus, and we turn around and provide that back to students through scholarships for students who want to do research with faculty members, travel grants for students who want to travel to professional conferences to present their work, as well as summer opportunities like the Summer Undergraduate Scholars Program. We also support service learning on campus and provide a lot of support for the EMS senior design courses. So that's always really exciting to see all sort of how all those things culminate at this very, very busy time of year. Obviously, you all know it's a crazy time of year for all of us, but it's certainly my favorite. I love seeing all the awesome ideas that come through in the hackathon. I love seeing the students present at the quick pitch competition, which is happening next week, next Wednesday. We've got our Pioneer Creative Activities and Research Day poster symposium going on all this week, and I encourage you to check those out. We've got over 100 posters there. There's just so much cool stuff happening on campus, and I love sitting in the position that I do and getting a chance to see all of it every year. It's just so exciting. I did want to make sure to say thank you to WiSys for sponsoring this event. My office works very closely with WiSys in a variety of capacities. It's always such a pleasure to work with Tony and Deborah Lundeen and Jennifer Sauter, and Arjun, and just the whole team there. They're great to work with, and so whenever they come to me and want to do something, I'll say yes, because I like working with them. So I'm super excited to see which groups win, and I won't say anything more so that we can get to those awards.
Fantastic. Thank you, Will. All right. And finally, sponsoring our first place $1,000 award, I'd like to welcome Arjun Sangha, president of WiSys, to say a few words on behalf of our organization.
Thanks, Tony. And thanks, Will. We enjoy working with you too. Terrific. With regards to the Platteville Chamber, Wayne, I can tell you how you got involved. It's a great story. The Prototyping Hackathon was an idea by UW-Platteville students who were WiSys ambassadors. They came to us wondering if we would help them create this event for engineers similar to the hackathon for computer scientists. And we said, wow, that's a great idea. Let's try it out. And they just got out ahead of us. They went straight to your predecessor and said, hey, could you help sponsor this? And she said, I'm not sure what it is, but she was so excited that students came to talk to her that she said yes. And you guys have been involved ever since. And we're very grateful because we think that this is a really wonderful way to engage the community and, with the students at UW-Platteville. So on behalf of WiSys, thanks everyone for participating in this afternoon's prototyping hackathon. It's been a great showcase of UW-Platteville's dynamic innovation community. It was great to see, they're constantly improving with the wonderful building that's coming up and the Innovation Center. I'm just excited to see that come into place, and the Idea Hub and winning a $1.1 million EDA grant to support all this. So that's just terrific. And I can tell you that we get questions all the time about, what is Platteville and UW-Platteville doing? Because your numbers are off the charts and you're really doing a lot in innovation. So it's events like this that give student innovators a chance to connect with other innovators, test their skills and present ideas, and that they're an important part of our work to inspire Wisconsin innovation. For those of you unfamiliar with WiSys, we're a nonprofit organization supporting the UW system that works with faculty, staff, students, and alumni to facilitate cutting-edge research programs, develop and commercialize discoveries, and foster a spirit of innovative and entrepreneurial thinking across the state. It's important to mention that our work is not possible without the strong relationships on UW system campuses that we serve. So I must thank our UW-Platteville partners, as Tony has already done some of that, but thanks again to Hal Evanson, who helped organize this event this year. We really are grateful for the strong connections that we have with faculty members who link us on campus like that. We're very appreciative of your efforts for making sure it's continued through this challenging time for everyone. It's also important to mention somebody who's been mentioned already today, Molly Gribb. She's on the WiSys Advisory Committee, and she's been a strong supporter of the Prototyping Hackathon, stretching back more than 5 years when we first launched this event. But the fact that this has continued to be such a strong event at UW-Platteville is a testament to your leadership. So thank you, Molly. We really appreciate it. And then finally, last but not least, thanks to all the students, all the participants. Your engagement and passion and your ability to adapt has been inspiring. Congratulations. It's just really exciting to see the ideas that you come up with and how much you've progressed through those ideas and the presentations that you make. It's really very impressive. Thanks, Tony.
Great. Thank you, Arjun. And again, thank you to all of our award sponsors and partners for this event. Okay, at this time, our judges have finished their deliberation and we are ready to announce the awards for the 2021 Prototype Hackathon. First, one more congratulations to all the students who presented today. You all made great strides in the last few weeks as you worked on your prototypes and prepared for today. And we commend you for taking part in the competition, in particular in this year's virtual competition. I know there's been a few wrinkles doing this virtually this year. So if I call your name or names, please turn on your cameras for a moment and give a wave so that we can capture a screenshot. Okay, here we go. In third place, taking home the $250 award is CycleSafe, the team of William Husin and Praise Obiladin.
We're here.
Congratulations to you.
Woo!
All right, then in second place, taking home the $500 award is Aurora Scrub, the team of Jacob Ubel, Matthew Nye, and Luke Behan. All right, congratulations, Aurora Scrub.
Thank you.
Thank you.
And in first place, taking home the $1,000 award, the winner of the 2021 Prototype Hackathon is GoBoard, the team of Evan Tenney. Congratulations, Evan.
Thank you all so much.
All right, if I could have our awardees stay on for a final screenshot capture, that would be great. To everyone else, thank you for joining us and have a great night.